analysis to find all the loop currents, that is I1, I2, I3. And so we can see that there is two loops. So loop is a closed path through which we will traverse only once. So this is a loop 1, and I will assume I assign the current I1 here, and this is a loop 2, and I will assign the current I2 here to this loop, and this is a loop 3, and I will assign the current I3 here. So the steps in doing the loop to solving any any problem using the loop analysis, the same problem can be found out using the branch current method. So that will be a different method, but we are doing the loop analysis to solve the problem. So the first step in doing the loop analysis is to write down all the equation for each loop. So to find the loop equation, you will apply KVL to all loops. So while I am applying the KVL to the first loop, what I will get is minus 100 plus, so this is rise in potential, so it's minus, this is a fall in potential because it is in the path of current. So from the path of current, the current will always flow from the positive to the negative. So if you are getting some understanding of KVL, so you need to see some previous videos about the KVL or the Kirchhoff's voltage law which I have made to understand more if you don't have that knowledge. So again here it's 10 and it's I1 is the current here, so that's a voltage drop, and I'm coming to this resistance. So the current I3 is flowing in this way and the current I1 is flowing in this way. So it will be 10 I1 minus I3 plus, again I am coming to this way to complete this loop. So this I'm coming across this resistance. There is two currents which is flowing. I1 is flowing in this way and I2 is flowing in this way. So it will be 10 I1 minus I2. So that was the equation of my first loop. Again the equation of my second loop will be ten I2 minus I3 if I am taking this resistance, and there is a fall in potential here, so it will be plus 50 plus 10 I2 minus I1. And for my third loop I will have the equation 10 I3 plus 10 I3 minus I2 plus 10 I3 minus I1. So these are the three equations which I have got. So these equations I can simplify and write it as, it's very much possible to simplify these equations, and so I'll just simplify it. So when I will simplify the first equation, it can be reduced to this form like 3I1 minus I2 minus I3 is equal to 10, and this equation can be simplified as this way, and this equation can be simplified as this way. So that's how I have got three equations, and now it's possible to solve this using the Cramer's method or matrix solution. So that's the one way. After finding out three equations, you can solve it using the Cramer's method for three loops, or for even more loops you will have to use a matrix solution, but you'll need special mathematical knowledge in the determinants and the matrix to do that. But if you're not having that knowledge, you can simply solve these equations algebraically, and when you are doing that, what you can find here is you can find that from this equation you can find, from this I'm taking this as the first, second and third equation respectively. So from third equation what you can write is the value of I1 you can find as I1 equal to 3 I3 minus I2. So I'm solving this equation, and from the second equation what you can find is I3 equal to 3I2 plus 5 divided by 4, and now you have both the values of I1 and you have both the values of I2, and this you respectively can become your fourth equation and this can become your fifth equation. And now when you are substituting the fourth and the fifth equation in the first equation, that is, you will have to solve for 3 into, you have to substitute the value of I2, which is 3I3 minus I2. So again you will have to solve that fully. So to and minus I2 minus the value of I3 is 3I2 plus 5 by 4, and again you'll have to substitute the value of I3 here. So this is equal to 10. So when you are doing that, what you will find on solving that is 9I3 minus 3I2 minus I2 minus 3I2 plus 5 by 4 equal to 10. So on solving this, what you'll find is you'll find that I2 equal to 0, and by again substituting the value of I3 here in this, you will get an equation in form of I2, and solving that you will find the I2 equal to 0. And after getting your I2 equal to 0, you can substitute it in this equation and you will find your I3 equal to 5 by 4, which is equal to 1.25. and when you have got your I3, if you are getting substituting, I'm writing here, so you have got your I2 equal to 0, you have got your I3 equal to 1.25, and now you are substituting in the first or in the third equation which you got. So what you will get is I1 equal to 3 into 1.25, which is equal to 3.75. so that is the value of I1. So based on your solution, you have got I1 equal to 3.75, I2 equal to 0, and I3 equal to 1.25. so these are my answers. So just highlighting this, so what you got here is the answer. So this was a full case of solving for the loop method, and what you found is that you identified 3 loops. This was the first loop which you identified, this was the second loop, and this was the third loop. Then you found out 3 equations. This was your first equation which you found out, then this was the second equation and the third equation, and you found out the equation by applying the KVL to the loops. Then you simplified each of these equations. After this is possible to solve this using the matrix method or the Cramer's method, and again you can algebraically simplify this as I did here, and you can find the solution. So again, if you are having three equations, it becomes easy to solve it using the simplification, but if you have like 4 equations, then it becomes necessary to solve that using the matrix, or the solution could get longer. So this was one example of how to solve an equation using the loop analysis method.